This video is over solving more complicated radical equations. The last video that we did was solving simple ones. Now we're going to just continue what we were doing before, solving equations that have radicals in them, only it gets a little harder. And just remember, you always have to check your answers on paper when you're doing these. Okay, so we have solve for x. We have the square root of 3x minus 5 equals 3 root x. And when we have radicals, the way we're going to solve them is we're going to square both sides. And remember, I keep saying that, sides. You're going to square the entire side. So if I square the square root of 3x minus 5, I get 3x minus 5. The square and the square root cancel. And if I square 3, I get 9. And if I square the square root of x, I get x. So you see now that the radicals are gone, we can just take away 3x from both sides. Negative 5 equals 6x, and divide both sides by 6 to get x equals negative 5/6. And you must check it. You must check it. I guarantee you there's going to be some on the test where when you check it, something won't work. Alright, if we've got the square root of 3 times negative 5/6 minus 5, and then equals 3 times the square root of negative 5/6. And you try to solve that. I'm not even going to try to work this out. It's ugly fractions and stuff, but the point being, when I multiply this, I get a negative number, and minus 5 is another negative number. That's a square root of a negative. And negative 5/6 is the square root of a negative. And you guys all know that you can't take the square root of a negative and get a real answer. So these are not real. And it doesn't matter if they're the same not real thing, they're still not real. So your answer is the empty set, or no real solution. We don't have an actual answer. If you were to graph this square root and this square root, they would never cross each other. Alright, next example, again solve for x. We have the square root of 4x minus 4 equals negative 2 times the square root of x plus 1. And because we have more than one square root in here, and we have some stuff that's not, we're going to have to square twice in this problem. So just expect that. Alright, remember I said you have to square both sides. And when I say sides, I mean put parentheses around the sides. But this side is a binomial. And when you square a binomial, you have to FOIL it. So we actually have the square root of 4x minus 4 times the square root of 4x minus 4. But on this side, we just have a monomial, so you can just square the negative 2 and get 4, and square the square root of x plus 1 and get x plus 1. Make sure you put that in parentheses too, though, because you're going to multiply both of those things by 4. So on this side, when we FOIL and we multiply the first two together, we're going to get 4x. Then when you do the outers, you're going to have minus 4 root 4x. And you're going to do the inner two together, you're also going to have minus 4 root 4x. And the outer two, negative 4 times negative 4 is positive 16. And then here, if I distribute my 4, I have 4x plus 4. So now, I only have, well, if I combine like terms, I will only have one square root in the problem. So I'm going to put these two together. I have negative 8 square root of 4x. And I'm going to take away 4x from both sides. Minus 4x, minus 4x. And I'm going to take away 16 from both sides. Minus 16, minus 16. So now these go away. These actually also go away. I have negative 8 square root of 4x equals, and 4 minus 16 is negative 12. So now I'm going to divide both sides by the negative 8. Your goal here is to isolate the radical. Isolate the radical. So we've got the square root of 4x equals, and then negative 12 divided by negative 8 would give you 3 over 2. Positive 3 over positive 2. Alright, so I'm going to have to go to the next page to continue this problem. So we have the square root of 4x equals 3 halves. Now we're going to need to square both sides. So when we square the square root of 4x, we get 4x. And when I square 3/2, I get 9 over 4. And then I want to divide both sides by 4, which is the same thing as multiplying by a fourth. So I have x equals 9 times 1 is 9, 4 times 4 is 16. X equals 9 over 16. All right. Now we need to check it. So we'll go back to the original, which was, here, let me write check. And we're going to plug into the original the square root of 4x, so the square root of 4 times 9/16 minus 4 equals -2 square root of x plus 1, so 9/16 plus 1. All right, if I take 4 and I multiply it by 9/16, I get 9/4. So the square root of 9/4 minus 4 equals -2, and 9/16 plus 1 is 9/16 plus 16/16, or you can just put it in your calculator, you get 25/16. So now I want the square root of 9/4, I'm going to move up here, and I get 3/2 minus 4 equals -2 times, and the square root of 25/16 is 5/4. 3/2 minus 4, if you want to just punch it into your calculator, you get -5/2. And -2 times 5/4 is -10/4, which is -5/2. So it works. We're happy. X equals 9/16, and we're done. And we're going to do one more example, one of these tough ones. So solve for x. We have the square root of x plus 6 equals the square root of 11 minus x, and then minus 3. So remember, we have to square both sides. And when I square the square root of x plus 6, I get x plus 6. But when I square the square root of 11 minus x, all minus 3, I have to FOIL. You have to. It will not work if you don't. So we've got equals, hold on, square root of 11 minus x minus 3 times the square root of 11 minus x minus 3. And we're going to go first. When I do the square root of 11 minus x times the square root of 11 minus x, I get 11 minus x. And then outer, when I do minus 3 times the square root of 11 minus x, I get minus 3 root 11 minus x. And then I'm going to have inner, which is the same thing. So I'm just going to go ahead and add those together and have minus 6 square root of 11 minus x. And then when I do my last, I get plus 9. So I have now just one radical. I need to isolate it so I can square both sides again. So if I add x to both sides, and I'm going to take away 11 and take away 9, then x and x makes 2x. And 6 minus 11 minus 9 is -14. So I have 2x minus 14 equals -6 square root 11 minus x. This is a very, very ugly problem. But that's okay. You can do it. We're going to divide both sides by -6. So these all on this side reduce by 2. That means it's x minus 7 over -3. And then these cancel, and I have square root of 11 minus x. So now we've isolated the radical. I'm going to move on to the next page where I square both sides. All right, we are going to square both sides, which isn't going to be all that pretty, but really we're just foiling x minus 7. And then squaring -3 and getting 9. And then when you square the square root, you have 11 minus x. So when I FOIL these on top, I get x squared minus 14x plus 49 all over 9 equals 11 minus x. Don't give up yet. I know it's not pretty. I'm going to multiply the other side by 9. X squared minus 14x plus 49 equals 99 minus 9x. And then I'm going to set it equal to 0 because it is a quadratic. I'm going to do that up here. So I have x squared And then I'm going to add 9x to both sides. Negative 14 plus 9 is negative 5x. And I'm going to take away 99 from both sides. 49 minus 99 is negative 50. So I want two numbers that multiply to give me negative 50 and add to give me negative 5, and that would be x minus 10 and x plus 5. So x equals 10 and negative 5. We have two answers. We need to check them both. So we will plug in the square root of, we're going to check 10 first, so we'll go 10 plus 6 equals the square root of 11 minus 10, and then minus 3. That's the square root of 16 equals the square root of 1 minus 3. 4 equals 1 minus 3. No. Check the other one. Square root of, we're going to plug in the negative 5 now, so negative 5 plus 6 equals the square root of 11 minus negative 5, which becomes plus positive, and then minus 3. So I have the square root of 1 equals the square root of 16 minus 3. 1 equals 4 minus 3. Yay, 1 does equal 1. So our final answer for this problem is not the 10, only the negative 5. So x equals negative 5 is it, and you are finished. And here's an early Valentine's Day message for you guys that you might want to use this in your Valentine's this year, especially if the person that you love likes math. All right, have a good night.